There are many phenomena around us that convincingly prove to us that our world is the creation of an intelligent being. These phenomena indicate not only that the highest mind, the organizer of the universe, exists, but also that he himself controls this universe. The cosmos is permeated with evidence of the existence of God. These testimonies complement each other, pointing to the certainty of the existence of the creator of this world. Someone had to sow these seeds so that they would germinate in that order. There are many phenomena all around us. They have a definite purpose, for which they were created. Such phenomena evidently inform us that the world was created by an intelligent being who knew how the end and the means correlate, and therefore created specific means to achieve specific goals. And now let's talk about the theory of the origin of the universe, which does not contradict either the divine or the scientific theory of the appearance of the world. Is our world real, and where did it come from? To understand what is going to be discussed, let's think about it. And what do we mean by real? If it's real, then it's something that you can touch and see. This is something that can be detected and measured by instruments. But if it's real, then where did it come from? After all, to create something real, you need some kind of real creator, to create a creator, some kind of creator, and so on down the chain. Or you need an ideal creator. But then the question arises, how does the ideal create the real? What are the explanations for the origin of our world? Religion believes that the world was created by God, but does not explain where God himself came from. Scientists believe that the world was formed as a result of the Big Bang, but they immediately add that their theories do not apply to the singularity that existed at the time of the Big Bang and before it. Transhumanists assume that it is our task to evolve enough to become God and create this world. Or you can build a picture of the world in which the creator would not be required at all. The simplest option is to assume that there is no peace. And if it doesn't exist, then you don't need a creator. This option corresponds to the Occam principle, according to which it is not necessary to add new entities unnecessarily to explain something, but contradicts the fact that we exist and we observe this world. Then there is another option. Our world is a mathematical abstraction, i.e., a formula, an idea, or something else like that. He does not need either a creator or a material carrier. Let's consider a simple example of mathematical abstraction. In 1975, researcher Benoit Mandelbrot used a computer to draw a set that was later named after him. This set is remarkable because it is described using a fairly simple iterative algorithm for converting points on a complex plane, but for all the simplicity of the description, the corresponding object has an infinitely complex structure. There are a lot of such formulas and algorithms open, and they are not all built on a plane. You can add a couple more coordinates to the plane and get something similar to our spacetime. By the way, from a mathematical point of view, time is described as imaginary space. Let's imagine for a moment that our world is just a mathematical abstraction. Most likely, the formula or whatever it is that describes our world will be more complicated than the description of the Mandelbrot set. We have not yet discovered this formula, but scientific research proves that our world lives according to certain laws, and these laws are quite strictly observed. This is an important circumstance. Firstly, it speaks in favor of the fact that our world can really be a mathematical abstraction, and secondly, it is thanks to the action of laws that we exist in it. In the absence of laws, intelligent beings cannot appear in chaos, since the main property of intelligent beings, as experts in artificial intelligence say, is to discover patterns in the world and use them in their daily activities. In the absence of laws, learning is impossible. Memory is useless. Attempts to form at least some structures, not to mention highly organized ones, will not succeed, since there are no laws thanks to which they could appear. Now let's assume that a certain function describes spacetime and certain objects in it, which over time are able to move around this space, form structures at all levels of the organization, both passive and active, able to collect information about the world and use it to improve their ability to survive. Let's assume that this is just a function that is not embodied on any material medium, but which nevertheless describes very real things. Further, if such a function exists, let's ask ourselves, who created it? And who created the Mandelbrot set? In 1975, it was built using a computer by Benoit Mandelbrot. But before that, in 1905, its formula was described by Pierre Fatou. And what happened before that? Before that, no one knew anything about him or even guessed. But this does not mean that it did not exist at all. As an idea, it has always existed, and the idea is immaterial. How immaterial is all mathematics, born from observations of the world around us. Thus, the question of the creator of the formula disappears by itself. There is no need for a creator for such things. There can only be a discoverer who is himself a part of the world described by this formula. Mathematicians have already tried to create mathematical abstractions describing manifestations similar to those of our world. If we accept that our world is just a mathematical abstraction, let's see how we can answer a few questions. Does the above mean that our world is a matrix, in the sense of the movie of the same name? That is it a virtual reality that is a real medium, for example, a supercomputer, or a huge mass of computers connected to a network? It is quite possible, provided that there is some kind of external reality inaccessible to our perception. But then we can ask a question, and that external reality, how real is it? If we live in the most external reality, then the answer will be, no, our world is not a matrix. The matrix needs a material carrier, and mathematical abstraction does not need it at all. And if there is a virtual reality inside the world, then this is just an integral part of it, which contains either part of the information about the real world or information about the fictional world. The virtual reality that we have learned to create in a computer at the moment has one important feature. In quantitative terms, for example, the amount of memory, speed, number of simulated objects, it is finite. A mathematical object can be either finite or infinite. For example, the Mandelbrot set, as a mathematical object, is infinite. No matter which part of it we take, when we enlarge it, we will find more and more small details. But it can be recreated both in virtual reality and on a tangible medium. On a computer, it will turn into a finite set, limited by the number of pixels on the screen, or the number of memory cells in which its image is stored. Strictly speaking, this will already be a model of the Mandelbrot set, and not itself. You can draw it on paper. And although paper and ink have a finer structure than the size of pixels on a screen or computer memory cells, even with a small increase in the drawing, we will see that the picture differs from a mathematical object. And with an even larger increase we will see that it has nothing to do with it at all. And this is also a model. Moreover, it is of poor quality. Please note, although it has a material carrier, unlike the ideally high-quality mathematical Mandelbrot set, which does not have a material carrier. This raises a question. How many copies does our world exist in? If we live in a nested world, it is quite possible for more than one instance to exist. If we live in the outside world, this question is meaningless. Look at the Mandelbrot set. There can be any number of computer images or drawings on paper, but these are just models, not a real mathematical object. In this sense, we or someone else can create as many virtual realities as we want, reflecting our world, but these will only be incomplete models of it. By analogy, the real Mandelbrot set, which the world learned about in 1975, has always existed as an abstraction, even when no one guessed about it. Where did it exist and in what quantity? Nowhere and in no way. Well, maybe about it. As a formula, we can say that it exists in one copy, meaning that if someone else wrote the same formula, it's still the same formula, and the amount from this fact will not double. Are there other worlds? As mathematical objects, of course there are, because there are any number of formulas. But they have nothing to do with our world, and it makes no sense to ask them where they are. Can our world intersect with another? Is it possible to get from our world to another? No. If it were possible, then the formula describing our world should include that other world, and if it includes it, then the other world is no longer another, but a part of ours. So what kind of world do we live in anyway? Are we real or are we just a mathematical abstraction? Unfortunately, due to Gödel's incompleteness theorem, the answer to this question cannot be obtained. But the real world requires an explanation of where it came from, and mathematical abstraction is self-sufficient and therefore more plausible. Do we live in virtual reality? For people with a limited number of neurons in the brain and with limited perceptual ability, even artificially created virtual reality, provided it is implemented with sufficient quality, may turn out to be indistinguishable from the real world. What can we say about the world of which we are a part and which, according to our knowledge of it, is quite subtly arranged? By conducting physical experiments, we penetrate further into the depths of the structure of matter, and even now scientists assume that space and time are quantized over small distances and short periods of time. This may be an argument in favor of the matrix and the nesting of our world into the outside world, but it may also indicate that the mathematical abstraction describing our world is discrete. Mathematical abstraction is an information concept. What about the fact that the information interactions observed in our world do not occur without the participation of material carriers? What we observe is secondary information that is encoded in the properties of objects and in their mutual location in space. The information interaction of objects occurs due to the fact that some objects encode others and others read this information. Such a process requires the presence of at least two interacting objects that have agreed on how the information will be encoded and how it should be interpreted. Without observing these two conditions, interaction ceases to be informational and degenerates into just interaction. Further, if the objects themselves, their interaction with each other, as well as space itself are the result of a certain function. Then we will come to the conclusion that there is also primary information that exists outside of spacetime, and therefore does not have a material carrier. In our world, it manifests itself, for example, in the form of world constants, but who knows, maybe there are worlds in which there is no information interaction at all, where chaos reigns. Similarly, we can talk about tertiary information. For example, for a gamer, characters in a computer game will interact informatively with each other, although any programmer will say that this interaction is apparent, but completely different processes are actually taking place at the signal level in the computer.